The NA62 experiment, known as P326 at the stage of proposal, is a particle physics experiment in the north area of the SPS accelerator at CERN. The experiment was approved in February 2007. Data taking began in 2015, and the experiment is expected to become the first in the world to probe the decays of the charged kaon with probabilities down to 10⁻12. The experiment's spokesperson is Augusto Ceccucci. The collaboration involves 333 individuals from 30 institutions and 13 countries around the world. Goals: the experiment is designed to conduct precision tests of the standard model by studying rare decays of charged kaons. The principal goal, for which the design has been optimized, is the measurement of the rate of the ultra-rare decay K plus pi plus nu with a precision of 10%. By detecting about 100 decay candidates with a low background in 2 years of data taking. This will lead to the determination of the CKM matrix element, VTD, with a precision better than 10%. This element relates very accurately the likelihood that top quarks decay to down quarks. The Particle Data Group's 2008 review of particle physics lists VTD equals 0.00874 plus 0.00026 minus 0.00037 experimental apparatus. In order to achieve the desired precision, the NA62 experiment requires a certain level of background rejection with respect to signal strength, namely, high-resolution timing, to support a high-rate environment. Kinematic rejection, involving the cutting on the square of the missing mass of the observed particles in the decay with respect to the incident kaon vector. Particle identification, hermetic vetoing of photons out to large angles and of muons within the acceptance, and redundancy of information. Due to these necessities, the NA62 experiment has constructed a detector which is approximately 270 meters in length. The components of the experiment are explained below. Beamline. The foundation of the NA62 experiment is observing the decays of kaons. In order to do this, the experiment receives 2 beams from the SPS. The primary beam, called P42, is used for the production of the K+ beam. The 400 GeV C proton beam is split into 3 branches and strikes 3 targets: T2, T4, and T6. This produces beams of secondary particles which are directed through the underground target tunnel, TCC2. At the exit of T4, the beam of transmitted protons passes through apertures in 2 vertically motorized beam dump collimator modules, TAX1 and TAX2 for P42, in which holes of different apertures define the angular acceptance of the beam and hence allow the flux of protons to be selected over a wide range. In order to protect the components of the apparatus, a computer surveillance program allows the currents in the principal magnets along the P42 beam line to be monitored and to close TAX2 in case of error. A secondary beam line, K12HIKA+, is kaon beam line. This beam is designed to come from a high flux of 400 GeV C protons in the north area high intensity facility, the target beam tunnel, TCC8, and the cavern, ECN3, where the detectors of experiment NA48 have been installed, have a combined length of 270 meters. It is planned to reuse the existing target station, T10, located 15 meters from the beginning of TCC8, and to install the secondary beam along the existing straight K12 beam line, of length 102 meters to the exit of the final collimator. which marks the beginning of the decay fiducial region and points to the NA48 detectors, notably the liquid krypton electromagnetic calorimeter, LKR. These beams led to 4.5 MHz of kaon decays in the fiducial region with a ration of approximately 6% for K+. Decays per hadron flux. Giga tracker, GTK. Placed immediately before the decay region of the kaons. The GTK is designed to measure the time, direction, and momentum of all the beam tracks. The GTK is a spectrometer and can provide the measurement from the incoming 75 GeV kaon beam. The measurements of the GTK are used for decay selections and for background reduction. The GTK is composed of 3 different stations labeled GTK1, GTK2, and GTK3 based on the order in which they are found relative to the beam path. They are mounted around 4 achromat magnets, which are used to deflect the beam. The entire system is placed along the beam line and is inside the vacuum tank. Straw tracker. Once the kaon's beam has gone through the decay region, the straw tracker will track the decay elements. The system measures the direction and the momentum of secondary charged particles which come from the decay region. This spectrometer is made with 4 chambers intersected with a high aperture dipole magnet. Each of the chambers consists of multiple straw tubes positioned 2 offer 4 views to give 4 coordinates. Out of 7,168 straws in the whole system, only 1 was flawed. The leaking straw was sealed and the detector operated normally during the 2015 run. Data. The experiment has run multiple tests to ensure that the new detector components were working properly. The first physics run with a nearly complete detector took place in 2015. The data collected is being analyzed and results are still preliminary. NA62 will begin data taking for the 2016 run in April. As part of the experiment, several papers have been and are in the process of being created. A list of published papers for the NA62 experiment can be found in the See Also section of this article. See also NA48 experiment, CERN NA62 home, NA62 website, NA62 and NA48 published papers. Further reading. Proposal to measure the rare decay K plus pi plus nu at the CERN SPS. PDF. CERN. The 11th of June 2005. CERN SPS C 2005-2013. Retrieved the 28th of September 2009. NA62 Technical Design. CERN. December 2010. CERN NA the 7th of October the 62. Retrieved the 29th of April 2011. Andreas Winhart. The 15th of July 2009. A precision test of lepton universality and KL-nu decays by NA62 at CERN. PDF. EMG Seminar. Retrieved the 28th of September 2009. NA62 website. NA62 CERN.